This is Mrs. Rubright with Advanced Geometry. Today's lesson is 5.1, Midsegment Theorem and Coordinate Proof. Alright, so we use the Midsegment Theorem to find lengths. So triangles are used for strength in roof trusses. In the diagram, segment UV and segment VW are midsegments of triangle RST. Find UV and RS. Alright, so UV and RS. Okay, so we're going to do UV first. So finding UV. It says that it's a midsegment, so it's made up of two midpoints. A midpoint splits it into two equal parts. So SU is congruent to UR, and SV is congruent to VT. Alright, so if this midsegment is parallel to this base, it is half of its length. So if this is 90, UV is half of 90 is 45. Make sense? So UV is 45. Do you guys see how I did that? The midsegment is half of the base, which is parallel to it. Okay? So if I'm looking for RS is down here. Its midsegment is up here, right? Alright, so if this midsegment is 57, double that, 114. So RS is 114. Do you guys see how I did that? The base is double the midsegment. Alright, so copy the diagram in example 1. Draw and name the third midsegment. So far we have, this is a midsegment, this is a midsegment. What's my third midsegment? So actually to kind of make this make sense, so that midsegment goes with that base. This base goes with this midsegment. And then I have a third base, right? This base goes with which midsegment? Well, the midpoint of this line is here, U. The midpoint over here is here, so these connect. So the midsegment would be WU, or UW. Make sense? It's made up of two midpoints. Weird. It shouldn't be connected, but oh well. Alright, and then here, in example 1, suppose the distance UW is 81 inches. Find VS. So if UW is 81, what is VS? If UW is 81, what is VS? Yes, 81. Because the whole base would be 162. Right? In a kaleidoscope image, AE is congruent to BE. AE is congruent to BE, which makes this a midpoint, right? Then it says AD is congruent to CD. AD is congruent to CD, making this a midpoint, right? It show that CB, show that this base is parallel to DE. Well, yes, they're parallel. Why? Because of the converse of the midsegment theorem, right? Because if these are midpoints, then this midsegment will always be parallel to the base, okay? So it says because AE is congruent to BE and AD is congruent to CD, E is the midpoint of AB, and D is the midpoint of AC by definition. Then DE is the midsegment of ABC, so by definition, the midsegment and the base are parallel by the midsegment theorem. Place each figure in a coordinate plane in a way that is convenient to find the side lengths. Assign coordinates to each vertex. So if I was going to do a rectangle, I would place the rectangle right here, right? So I have 0, 0. Then I would call this, what do you want this height to be? It could be whatever the heck you want, right? So what do you want it to be? You want to call it Z? So it would be like 0, Z. And then this you could say is P, or whatever letter you want. So you could say that this is like P0. So this would be what? PZ. Make sense? So this height here is a height of Z. This length here is a length of P. Right? Make sense? Whatever letters you want. How about a scalene triangle? No equal sides. Well, we can do 0, 0. And then maybe 0, 2. and so that's a length of 2. And then maybe we can do like 10, 0, right? This has a length of 10, this has a length of 2. If I did a nice little Pythagorean theorem, 2 squared is 4, 10 squared is 100, 104, so the square root of 104 would be this. Obviously, all different size lengths. All right. So they use K and H. It doesn't matter what letters you use. You see how they did this? Okay, in example 2, F is the midpoint of CB. CB, F is the midpoint, breaking it into 2 equal parts. What do you know about DF? This is a midpoint. What do you know about DF? It is a... What is DF? If this is a midpoint, what is DF? It's a midsegment, therefore it's parallel to AB, right? It is half the length of AB. A square has the following vertices. Find the fourth vertex. So we have 0, 0. We have M0. We have 0, M. It's a square, right? So this length is M, this height is M, right? So what's this? This would be over to M, up to M. M. Is your missing vertex. Make sense? Place an isosceles right triangle in a coordinate plane. Isosceles right triangle, 90 degrees, 2 equal sides. This length is K. This height is K. Right? Isn't this a 45, 45, 90 if it's x rad 2, right? K rad 2 is this distance, just saying. Now let's see what they want. They want to find PQ. Well, PQ is K rad 2. I can do that just knowing that this is a special right triangle. This is a 45, 45, 90, x rad 2, right? If I was going to use the distance formula, I just plug this into the distance formula. This is your x, y, we'll call this point 1, we'll call this point 2. x2 minus x1 squared plus y2 minus y1 squared square root, distance formula, right? K squared is K squared. Negative K squared is K squared. K squared plus K squared, you have 2 K squareds, square root. So it's really the square root of 2 times the square root of K squared. Squared and square root cancel each other out. So K rad 2, which is what I knew just from it being a special right triangle. Right? Back from algebra 1 when we learned 45, 45, 90s. Use the midpoint formula to find the midpoint of the hypotenuse. Alright, so you can use the midpoint formula where you add your x's divided by 2, k plus 0 is k divided by 2 is k over 2. 0 plus k is k over 2 is k over 2. So it's half k, right? Halfway over to k over 2, comma k over 2. Make sense? So you can use the formula, or you can just look at it and see that it's halfway there. Write a coordinate proof of the midsegment theorem for one segment. Okay, so it says DE is the midsegment of OBC. OBC. DE is a midsegment. Well, if it's a midsegment, then this and this are equal. This and this are equal, right? This is parallel to this. This is half of this. All right, so they're saying to, what are we trying to prove? We're trying to prove that they're parallel. We're trying to prove that it's half, right? Because we're proving the theorem, so we can't use what we know. We're just trying to prove that, and we're trying to prove that that's half. All right, so what do we know? You're finding the midpoints. Use 2P, 2Q, and 2R, then find the coordinates of D and E. So they put points, they put coordinates on here, right? So if I was finding the midpoint, I add my x's, divide by 2, add my y's, divide by 2. So 2R divided by 2 is R. 2Q plus 2P divided by 2 is Q plus P, right? Over here, you'd have Q comma R. Right, add your x's divided by 2, add your y's divided by 2. So you have these points. You can find out their distance throwing it into the distance formula. You can use, right here, you can do the distance formula here to find out that this distance is 2p, right? You're going from 0 to 2p, it's 2p. So you're going to show that this equals p by using the distance formula with these two. And then it proves that it's half. Does that make sense? So you're literally just doing the math. All right, so graph the following points. So O is at 0, 0. J is at M0, so you go over to M, up nothing. And then this would be over to M, up something. They're calling it up N. Stay put, guys. So you graph that. And then they want to find the side lengths. Well, here, this length, you're going up to N. So this is a length of N, right? Over here is a length of M. And then you can do Pythagorean theorem. M squared plus N squared square root, right? So HO is going to be M over 2 comma N over 2. And that is everything. So I hope you guys enjoyed your lesson on 5.1 Midsegment Theorem and Coordinate Proof. Have a great day. Like and subscribe.